Well, hey, Math 8, Mr. Erickson here. Welcome to the midweek feedback video for April 27th to May 1st, with our main goal here being to just prepare for Friday's quiz. So let's see if we can do that here by going over some practice problems, really from Monday's assignment, which was the last lesson, and then from Wednesday, which was our review assignment preparing for the quiz. So Monday's assignment, first of all, the questions 1 and 2 I had to manually grade, and I've got, at least when I'm recording this video, I've now gone back and graded all those. So if you haven't used all 3 attempts and you didn't get one of those right, you actually can go back and do another attempt on Monday now that I've kind of gone in there, given some feedback comments for some of you. Some of you guys did a great job. Already got 2 out of 2 on both number 1 and 2. You probably don't have to worry about this slide right here. But anyways, I'm going to go over these, and then you can always go back and once again do another attempt if you want to get a higher score on Monday's quiz there. So number 1, we don't actually have to calculate these. We just have to decide, are they mutually exclusive or not, and then explain our reasoning, right? Be able to back it up. Okay, essentially the question for that just comes from this very last sentence. So number 1, it says it's a nickel or it's US currency. Number 2 comes from the last sentence here that it's lemon lime or orange. So let's look at the first one. The question we're asking is basically this: is it possible for something to be a nickel and to be US currency at the same time? Now, if you're like me, it's kind of like a duh question, right? Most nickels are US currency. Now, I know there's some Canadian nickels, but obviously nickels we know as typically as US currency. That means there's definitely what we call overlap. So in this case, we definitely have overlap, right? It's possible for a nickel to be a nickel and to be US currency. So this would be an example of non-mutually exclusive, and we would say once again, because it's possible to be both a nickel and US currency. So that would be the answer for that one and the explanation. Number 2, same kind of idea. Is it possible for a flavor to be both a lemon lime flavor and the orange flavor at the same time, right? In this case here, it's either the lemon lime Gatorade or it's the orange Gatorade, right? It's not both. You don't mix the two. So in this case here, there's what we would say is no overlap here, right? It's not possible to be both lemon lime and orange at the same time. So that's what we call mutually exclusive. There's no overlap between the two. Okay, that would be 1 and 2 on Monday's assignment. Looking at the stats here, number 6 was also a tough one here on Monday. Let's talk about this one. Says a bag contains 5 yellow tickets numbered 1 to 5, and then 5 green tickets also numbered 1 to 5. Okay, let's say it's yellow or it has a number less than 4. So first of all, to figure out, is it mutually exclusive or not mutually exclusive, we would have to say, is it possible for it to be both yellow and a number less than 4? Are there yellow tickets that are less than 4? Up here it says there's 5 yellow tickets that are numbered 1 to 5. So there's definitely some that are less than 4. So that means there's some overlap here, right? It's possible to be yellow and a number less than 4. So that means our answer here, first of all, for part A, would be that it's not mutually exclusive. What that means is we're going to have to subtract the overlap before we report our final answer. But let's start with just figuring out the fractions first. So yellow, first of all, we know that 5 out of the 10 tickets here are yellow. And of course, I guess we just leave it right there. 5 out of 10 are yellow. And then we're going to add that here with the probability then of the second thing, which is how many of them are less than 4. So there's 3 tickets, because yellow goes 1 through 5. So 1, 2, and 3 on the yellow side, there's 3 there. And then 1, 2, and 3 on the green side, there's 3 there. 3 and 3 would be 6. So 6 of the 10 are less than 4 between the two colors. So obviously here we would do 5 plus 6. We got our common denominator. We can just add the numerators, do 5 plus 6. That would be 11. However, we know we can't have a probability that's over 1. We can't have 11 over 10. And that's kind of, once again, a pretty good giveaway here that we're probably missing something once again. And because it's not mutually exclusive, we have to subtract that overlap. And so the overlap here would be how many are both yellow and less than 4. And so it would be on the yellow side, you'd have 1, 2, and 3 that are all less than 4. So basically 3 out of the 10 total cards are both yellow and less than 4. So in that case here, we can add together 5 plus 6 is 11, minus 3 would give us 8. So we end up with 8 over 10. Now, before we say that's our final answer, we want to reduce. You can divide those both by 2 since they're both even. And we're going to get our final answer here as 4 over 5 as our probability. All right, one more from Monday's assignment, and then we'll look at just a couple from Wednesdays. We actually did pretty good on that assignment overall so far. But this one here was kind of a tricky one here at the end of Monday's assignment with the spinner. So the spinner is spun one time. Assume that it does not land on a line, so it lands in one of the sections here. Find each of the probabilities. So first, that it lands on an even number or an unshaded section. So let's figure out mutually exclusive or not. So is it possible for it to be both an even number and an unshaded section? If I look over here, it looks like all the unshaded ones are actually all the odd numbers. So we would say this is mutually exclusive, which means we can just add those two together. So the even numbers, 5 out of 10, I think, are even. Be 2, 4, 6, 8, and 10. Plus, how many are unshaded? There's basically all the odd numbers. There's another 5 out of 10. Put those together, you get 10 out of 10. But we know we can simplify that. What's 10 divided by 10? It's just 1, which basically means you're guaranteed. If you just randomly spin that spinner, you're guaranteed to either land on an even or an unshaded, because basically all the unshaded are the odds. So it's like you're either going to land on an even or an odd number. You're guaranteed one or the other. So we would just say the answer for part A there is just 1. All right, second one. Part B, it lands on a shaded section or a prime number. So the shaded sections would be 5 out of 10? I'm going to do this one down here where I've got a little more room. Okay, 5 out of 10 plus the prime number here would be 2, 3, 5, and 7. That's 4 out of 10 of them. But now we need to decide, is it mutually exclusive or not? Was there overlap here that we need to subtract if it's not mutually exclusive, if there's some overlap? So let's look here. Is it possible to be both shaded and a prime number? For example, 2 would be an example of something that is both shaded and a prime number. Let's see if there's anything else. I actually don't think there's anything else. 3, 5, and 7 are all unshaded. So there's just that 1 that we'll have to subtract. So you do 5 plus 4 is 9, minus 1, though, is 8. And just like we did on the last one, we can reduce that down to 4 over 5. Since they're both even numbers, we can divide them both by 2. So that's part B. Part C would be a multiple of 3 or a shaded region. So multiple of 3, let's see, would be 3, 6, and 9. There's 3 of those. Okay, so 3 over 10. Okay, plus then a shaded region, there's 5 of those. 5 over 10. Okay, that would give us 8, of course, but let's check really quick. We might have to see if there's overlap. So it looks like 6 is something that's shaded and a multiple of 3, so we have to subtract 1 again. So 3 plus 5 is 8 minus 1, though, because we have that 6 right there that is both shaded and a multiple of 3, would be 7. So 7 over 10 for that one. All right, and then part D, I know it's getting a little crazy here. Let's go ahead and do this in another color. Part D, we're going to take that down here. Okay, so it's unshaded or a prime number. Okay, so unshaded would be 5 out of 10. Okay, a prime number, once again, is 2, 3, 5, and 7. So there's 4 out of 10. But then is there overlap? Is it possible to be both unshaded and a prime number? And it definitely is. 3, 5, and 7 are examples of that. So there's subtracting the 3 overlap. So 5 plus 4 is 9, minus 3 was 6. So 6 over 10, they're both even. You can reduce that to 3 over 5. All right, I know there was a lot there, but that was once again the toughest question, at least according to the stats for you guys on number 9 on Monday's assignment. Let's move on, finish up here with just a couple from Wednesday. Overall, so far, we've done pretty well, and this is kind of reviewing for the quiz. It's basically what you're going to see on the quiz here, more or less. All right, first one goes back to talking about independent versus dependent. So we've got 8 red marbles, 6 blue marbles. You randomly pick a marble, then pick a second marble. Then here's where you figure out is it independent or not. Notice here, without returning the marbles to the bag. If you don't return them, now the probabilities are changed the second time, right? The second probability depends on the first one. We would say that is dependent, right? Okay, so we want the probability that you would get a red and then another red. So first of all, there's 8 red marbles. That's out of a total of 14. Remember, for these ones, we would multiply, not add. This was the older stuff. Okay, so we multiply the 2. Now the second one, it's dependent, so it's going to change a little bit. We're down 1 marble from 14 to 13, and we want a second red one, and we are assuming we picked out one of the red ones, so we're down to 7 red ones. Before we try to multiply, let's see if we can kind of just cross-cancel anything that we can. 7 and 14, that's 1 and 2, and then actually 8 and 2 would be 4 and 1 there. So once we kind of simplify everything we can there, we end up with 4 over 13, it looks like. 4 times 1 on top, 1 times 13 on the bottom. And that would be our answer for number 2. Number 5, overall we did pretty good with our sampling methods. Remember, if it's 2 students in each homeroom, notice that little phrase right there, right? In each homeroom, that would be stratified random. Okay, so remember, strata refers to groups. We talked about that one in one of the other midweek feedback videos. So stratified random, remember, strata refers to groups. And here, in this case, each homeroom is a group. You have to pick 2 students from each group or from each homeroom. That would be a stratified random sample. All right, last one here. Box of chocolates here contains, I'm just going to check time here, making sure I'm all right. All right, box of chocolate contains 5 milk chocolate and 4 dark chocolate. 2 of the milk chocolate and 3 of the dark chocolate have peanuts inside. You randomly select and eat a chocolate. So we want to know the probability is a dark chocolate and has no peanuts inside. Let's start with those. Let's figure out, is it mutually exclusive or not? So once again, the question, is it possible for it to be a dark chocolate and have no peanuts inside? So let's go back and see what it says. It says 3 of the 4 dark chocolate have peanuts inside. Remember, there's 3 that have peanuts, but there's 4 dark chocolate. So it is possible there's that one sitting there that is dark and it has no peanuts inside. So we would say there's some overlap here. So non-mutually exclusive. So we'll figure out the 2 fractions and we'll subtract that overlap. Right away, I guess that overlap, what ended up just being that 1 that we'll have to subtract because there's 1 dark chocolate that has no peanuts inside. All right, first of all, dark. There's 4 of the 9, it looks like, that are dark. Plus, and then let's see, we've got no peanuts inside would be, so 2 of the milk chocolate and 3 have peanuts inside. So 2 plus 3 is 5. So 5 out of 9 have peanuts inside. Oh, hold on, that's have peanuts inside. I want actually the opposite. I want the ones that have no peanuts inside. So actually, we're going to make this the other 4 would have no peanuts inside. So 4 out of 9. So 4 out of 9 plus 4 out of 9 is 8 over 9 minus 1. That would give us 7 over 9 as our final answer for that one. As always, if you guys need help, don't be afraid to reach out, either email or hop on Zoom during my office hours. I'd love to help in any way I can. Otherwise, I hope you guys have a great week, and we will see you next week. Good luck on the quiz.